Hello, I'm Prince. In this video, we'll see how to create chat to order web app. So this application is about how to create food order via chatbot. So basically, in a websites for websites like Zomato or Swiggy, we follow a very traditional method. Select the food items, then go to the uh, checkout section, and then payments and done. But I was thinking, like, can we do with the chatbot? Just try it. Okay, you can see here, I want to order a dosa. Then it is giving me order summary. I said confirm order. Again, double check. Okay, confirm the order. So I have to click on the button and then confirm. And it's look like we have already completed. And then I can see that order here in your orders. So I have done food order via chat. So that's the main motive for this application. And in this process, I'm using few AI models like intent classification, name and recognition, and also we have done you know reg implementation. Uh, then there is a chatbot, chat between bot and users. So there are like few things working parallel and together. So that we will explore in this tutorial. Also, this can be done by Google's Dialogflow, but in that is that is a pre-built things. So in that we don't have to create any other models or anything. I didn't use that because I wanted to create from the scratch, and for that, uh, I have created and trained the models, and yeah, let's see a demo. So I'm just refreshing the page. Okay, hi. Okay, so I want to order dosa and veg momos. Wow, look at this. Okay, yes, please confirm. Okay, I have to write confirm order specifically. Okay, yeah. So here is 6 6. Look at the orders 11 to 5. Okay, we can see we have just created an order from the chat. So that was the cool demo. I think. So in tech stack, to build this website, we are using React for frontend, Flask for backend, Chroma for vector DB. Uh, for vector DB, we have few options like Pinecone, Vivid, but I'm using Chroma. It is easy to implement, and for a small application, it's work good. Uh, then MongoDB. Still here we can use SQL, but I'm using MongoDB because it's flexible to write, and here we don't have any constraint, so we can go for MongoDB. Then we have created I've created two models, name identity recognition and intent classification. So we'll see how I've created those model from data to that model file. And about the architecture of this application, so basically user and bot is chatting, and in between we are tracking the user's message. Like, the first thing I'm doing is detect the intent of the user message. If there is an intent is create order, if remove order, confirm order, or no intent. For example, these are the four main intent I'm tracking. Okay, for a create order, I am running one another AI model, NER. So for example, I want to buy dosa and veg momos. So here dosa and veg momos is a food item name. Okay, so how this will extract those names by using this model NER, named entity recognition. This is a NLP model. So we'll see how to build this. And then I'm doing a MongoDB post request. Uh, you know, in a demo, we've seen that we can also see our order in your orders. So this is possible because of this flow. And then the end. For a remove order, we will ask to to give specific order ID, and then we will delete it. And for a confirm order, I have put one double check, like we'll give one button to make finally order. This we have also seen in the demo. And if there is a no intent, then we will ask to user to clear the message. I mean, for example, messages like thank you, hi. So these are the no intent messages. So for that, we'll keep asking to user that, okay, what next, what next. So yeah, this was the architecture and tech stack. So let's explore the folder structure. I believe any application should have a good folder structure because in a production we work together in a team. So we follow software engineering rules to maintain good quality of code. So here uh, in a front-end folder, uh, in a React app, in a source folder, we have two main folder, component and pages. So total we have about auth, home, orders, and profile pages. And in a component we have a chatbot, navbar, and protected route. So also this app has authentication because to see every user has a different identity, and also they have a different orders. To show that, I have also implemented authentication. And in a backend we have a lot of things because we have I have created the models. So in backends we have a chatbot, intent classification model, named entity recognition model. Then there is app.py, which is orchestrating these all models and chatbot together. And then there is a requirements.txt file. So okay, yeah, this was about the folder structure. And then there is a chroma. So uh, this is we have used for the rec. Yeah, overall this is about the folder structures. So first we'll start to explore chatbot folder. In this folder, we'll see how I have implemented reg, how I have used ChromaDB, and also I have used LangChain to create this chat and manage this chat between user and bot. So just first we'll look. So this is the food.txt. For example, here I want to tell you one thing. This is the menu which we can see here. Okay, this is in text format. So what we will do in a practical dot ipynb, here I have imported all the required libraries. Okay, then we are using Hugging Face and a Grok. Okay, then I'm splitting the chunks, okay, in a 300 length, and I have splits the chunks, and then all mini lm l6v2. This is the Hugging Face free mod for creating the embeddings. So that I have created using Hugging Face model, and then I have stored in uh, you know vectors. Then I have created the embeddings, then I have stored two vectors, and I have created one retriever. So retriever means you can, assume that get request in API. So in get request, what we do, we ask something and we'll get something. So retriever is work like that. Then we have LLM chat grok. I'm using this model for a chat. Then we have a contextualized system prompt. So you guys already know that we should have system prompt, then few instruction, and then there is a context, and then we do query. Okay, like here, system prompt, history, chat history. So here, how it knows that confirm the order because it has this all history. Okay, then history aware retriever. So in a LangChain, we are using the history aware retriever. Okay, then there is a one system prompt, then question answer prompt. So system prompt, chat history, and the our user input. Okay, and every user has a different session ID. So if there are multiple users are chatting with the chatbot, then we can separate those all history by session ID. And then there is a ask question function in which we have to just call it this function, and we have to give user a message, hi, then I got, you know okay, hello, welcome to our food ordering service. Okay, so this was the practical file. And in a setup file, in a in a live time, I'm using this only file. This file was for only to building time. Yeah, and you can see, so we have to call this initialize LangChain. Whatever process we have done in this file, that we do in this file one time when we'll run the app.py file. All the things as mentioned, same as we have done in practical file. So this was the chatbot folders and chatbot, you know how the I have built. Let's see intent classification model. So this is classifying the intents in three main intents: create order, remove order, and no intent. And this is the process to create the data. Here there are few templates. Order this, then we'll use any random food name. You can see there are many curly brackets where we'll use the random food names for everything, like for remove order, for no intent. Okay, from that particular arrays. Then we are creating the 500 500 500 for every intent, and then we'll have around 1500 rows. So which you can see, then it's a distribution. So we can see like create order sentences has a short length as compared to those two. Here, okay, we are using the DistillBot model, which is from the Hugging Face. It's a free model. It's a short model as compared to BERT. It's a distillation version, and it is capturing the 97% accuracy from the BERT model, and it's called a teacher student architecture. Even you can do um, even if you want to know more, then you can search distillation process. Now we will convert those all sentences into tokens. For 101 tokens means starting of the sentence, and 102 means ending of the sentence. Then we have model distill. We are, importing the weights, and this model has weights of that distillbot model. Then there are a few other functions which I'm running, extract the hidden stats and everything, to create the no create the data ready for training. So here you can see intent, hidden, text level. There are total 6 or 7 columns, and these are the all things we have to follow from the transformers library, training, trainer, training arguments, and these are the classes, and this all things are mentioned in Hugging Face library, how to uh, you know how to train the model and how to fine tune the model. Then test and train. We have 3 level: create order, remove order, no intent. These are the training arguments. We will run till 5 epochs. Learning rate is 2e minus 5. 2e hyphen 5. I mean, there is a 0.00 up till the 5 dot value from the left. Then batch size, weight decay. Okay. Uh, train dataset, valid dataset, and we are training, and we'll save all the weights, the fine-tune intent, classification model will save as this name, and now we will import that model to test, or the test data. And we can say I would like to order pizza. So create order. Please remove pizza from the order. So it's remove order intent. What's the price of the classic burger? So it's like it's showing that it's a no intent, so it's working fine. And this is the process to create the intent classification model. So here we have fine-tuned the distillbot model from the Hugging Face. Yeah. So now we'll see how to create NER, named entity recognition model. So here I'm using spaCy. There is a model called English Core Web SM. Then I'm importing the food.csv. It has food names. We will only extract those names which is you know more word length maximum 3. If there is a word as a 1 length, 2 length, or maximum 3, you can see 1, 2, 3. So there are total, I think we have extracted more than 50,000, but we'll only keep 30,000 for training. You can see blueberries, crackers, all the 1 word length, and at last we have a 3 word length. And again, there are a few templates. Here we are creating the data, and we will replace curly bracket with the food name. So NER means, for example, I want to order food. I want to order dosa and veg momos. So here dosa and veg momos are the food names. So basically we have to extract those names, because then after we can query into database. Okay, these particular name, food names items, is this available in DB? So for example, here we have used dosa and veg momos. So we are extracting the uh, price. You can see dosa 5.99, veg momos 4.99. Yeah. So for that we are doing this process, NER, named entity recognition. Yeah, then we are labeling with the food label. This means starting, ending. Can I get a golden oolong tea with no onions? So from 12 to 29, so we'll count like 0, 1, 2, 3, 4. So whenever there is a 12 to 29, we'll extract that, and we'll call it food label. Then same, we will import that model, uh, train with the our new data, and then we'll save this model, and again we'll do testing or the testing data. For example, you can see I ordered basmati rice, leaf spinach, and grilled chicken cheese from the sushi bar. So these are the few food names. And yeah, and also I'll create one function. I have created one function in detected.py. So extract food entities, uh, normalize text, then there is a NLP model, pass this normalized text to that model, and we'll get food entities. So this was the process for to create named entity recognition detection model. So now we'll see how app.py is orchestrating these all things together. So we are using Hugging Face and Grok, then MongoDB. These are all the setup things, tokens and keys. Then we are connecting the MongoDB with the PyMongo. So for the home route, there's nothing like server is running. We are just passing that string. So here we have also done the authentication. So register and login route. Then there's a products route. So products from the products route, we'll get all these products from the database. Then there's a chatbot. So every message the users are doing will get from the chatbot route. Here we are calling the red chain. Then user intents, we are predicting the text. If there is a confirm order, then we'll add the backend action string. So these all things I know I have mentioned in system prompt that if you find backend action, so it means I am you know I'm doing a post or a delete in DB. So there are three things: simple bot messages or user messages and backend action. Then for a create order, there is a some process to extract the name, find in a DB, and to give a summary, order summary like this. For a remove order, we'll find that particular order ID in DB. We will do remove. And for a confirm order, we will create the order, and still every action has a backend action. And yeah, and to get the all orders, there is a user orders slash user ID. Okay, and yeah, this was the whole architecture. And in a front end, this one component is useful, main component. These are the few stats: is stat open, messages, user message, loading, last create, order ID. And the thing is, we are calling the confirm order function and handle send messages. So handle send messages will run every time when user is messaging, and when we will get the intent create order, that time we will show this in a front end. I'll show you messages is order card. That time we are showing, look at this is for a summary, is button, and confirm order. Yeah, so once they click on the confirm the order, that time we'll call this function and pass the food items and everything. This is ref for scrolling continuously whenever there is a model whenever there is a chat pop-up. And yeah, so this is easy component. So this was the whole process from front end to back end, orchestrating the models. And yeah, so this was the whole demo which you can see. Yeah, bye bye.